All right, welcome back to another exciting edition of, well, you know the routine by this point. This probably is not your first turd Ferga vision. Anyway, I'm going over just a bunch of power rule and sine, cosine, log, exponent, just a bunch of derivatives. We're just taking the first derivative here of all these examples. Uh, so let's go ahead and get into it. So let's look at this one to begin with, right off the bat. Now, first, I want to make sure you notice something. There is a minus in this thing. So these are two. We'll look at each of these independently. So I've got to do something. I'm going to take a derivative of this, and then I'll end up, whatever the derivative is of this one, I'll also then subtract the derivative of e to the x, which right off the bat, I love this question because the derivative of e to the x is e to the x. So that's a super easy derivative to take. Now, on the other hand, the derivative of this one, it's x times e to the x, which means the first thing that should pop into my head on this one is a product rule. So since this one is a product rule, I'm going to have to kind of do a little work here. That's going to be my u, and e to the x is going to be my v. So I'm going to slide over here. My u prime would be 1. Now, this is cool. V prime, since v is e to the x, v prime would also be e to the x. So I've got my product rule. So u prime v plus uv prime. Let's see what we can't do here. So u prime is 1 times v, which is e to the x, plus u, which is x, times v prime, which is also e to the x. So it looks like I've got e to the x plus x e to the x. And now we'll go back, put this thing back together. So minus the derivative of e to the x, which is, now this is a cool answer. E to the x minus e to the x. Oh, goodness. You're gone. So my answer is just y prime is equal to x e to the x. So the derivative of x e to the x turns out to be x e to the x. That's just crazy. All right, let's move on to another one. So here we've got another one. We're going to take a first derivative of this guy. So first off, let's do this. The derivative of log of anything becomes 1 over e to the x times the derivative of e to the x. So what is the derivative of e to the x? Well, e to the x theoretically times the derivative of x, but that's 1. Holy cow, check this guy out. It's ex over, so the answer is 1. So the derivative of log e to the x, and if you want to have fun, I would say go graph. If you've got your TI sitting there handy or something, go ahead and graph log of e to the x and check it out. This should be interesting. So anyway, let's keep moving on. I love graphing functions. I guess it's a hobby of mine. Kind of like this stopped up nose I have right now. Anyway, next one. Oh, this one's easy. First off, do the derivative of log of 2x squared. Well, that's easy. It'd just be 1 over 2x squared plus 3 times the derivative of 2x squared plus 3, which would be 4x. So my answer is 4x over 2x squared plus 3, and that would be h prime x, and that is my answer. Hey, I'm on fire. Drink a little coffee, keep going. Now, this is neat. I'm always asking, what's the first thing pops in your head? X times log x, which means this is a product rule question. So I'm going to say that u prime is 1. V prime would be the derivative of log x, which would be 1 over x, times the derivative of x, which is 1, so that's no big deal. So let's write our product rule, uv plus uv prime. So let's go with u prime, which is 1, times v, which is log x, plus u, which is x. Now this is cool, times v prime, which is 1 over x. So this gives us an answer of log x plus, if you take a look, we've got those x's cancel. So this ends up plus 1. So y prime So there is my derivative, log of x plus 1. I must be getting excited. I keep getting my pin cord wrapped up in a giant knot here. Ooh. Now, what's the first thing pops into your head on this one? Well, when I see it, I see log t divided by t squared. So I see a u over a v in this one. So I'm thinking the quotient rule. So take my derivatives. U prime would be 1 over t times the derivative of t, which is 1. Let's see. V would be, or V prime, excuse me, would be 2t. All right, awesome. So let's come back in here. Let's do our quotient rule. U prime V minus U V prime over V squared. So let's do some substituting here. U prime is, I'm going to go to blue, 1 over T times V, which is T squared, minus U, which is log T, times V prime, which is, this one may not turn into anything very pretty, over V square, which would be 2 T square square. T square square is T to the fourth. And, let's see what happens here. Let's see. Over here, let's see, that T cancels that square. I don't see too much more pretty stuff happening on this one here. So this ends up being 1 minus, I'm going to rewrite it, 2t log t over t to the fourth, and that is actually going to be where I stop this thing. Somebody could come back and try and bring it further, but I do not see anything that would actually simplify this problem. So this is my final answer, Mr. Trebek. All right, moving and rolling here. All right, when you first take a look at this one, I got a feeling your impulse is going to be to try and come into this one and be like, oh, this is a product rule. It's 5 times tangent 3x. No, you don't have to think product rule with this. Think simple. If you saw 5x cubed, would you be thinking product rule there? No, you would just 15x squared is all you would do. Well, it's same situation here. This is not a product rule. This 5 to the tangent is no different than this 5 to the x. So my answer is going to be 5 times, what's the derivative of tangent? Well, that would be secant square, I'm going to put a little parenthesis there, 3x, times the derivative of 3x, which would just be 3. So my final answer is 15 secant square 3x. Again, you didn't have to put that in parentheses. I did it just to make it a little bit prettier looking. So I'm going to go ahead and box this. Have you had enough, or do you want more? Oh, I can tell. You want more. So I'll tell you what, I'm just a guy. I'm going to give you more. What is this? G of theta? So somebody wants us to take a derivative with respect to theta. All right, well, that's no problem. It's just notation. Now, first of all, when I see this, I don't see product rules. All I see is I want the derivative of cosine square 8 theta, which means I'm going to rewrite it like this. So this is how I'm going to work it. So let's see if I can do this now. This is just a chain rule question. So this would be 2 times cosine, I'm going to drop those little parentheses, cosine of 8 theta, 2, and then of course we subtract 1 from that, which is why we're just 1 here. Now, times the derivative of cosine 8 theta. Well, the derivative of cosine 8 theta, derivative of cosine is negative sine 8 theta. Now this is interesting. Times the derivative of 8 theta, which the derivative of 8 theta, see if I can do this, the derivative of 8 theta would just be 8. Now I see something pretty neat in this one. 2 sine theta, cosine theta. Wait a second. I've got a, oh my goodness, these sneaky little jokers. This right here, that's an identity from Trig class. So pre-cal, whichever class. Can't remember. I took them like 20-something years ago. Anyway, we know that sine 2x is equal to 2 sine x cosine x. And so that means I can do that here. Yeah, I know there's a negative there, and then 8. Well, I'm going to leave them alone. So my answer is going to end up being negative 8 times sine of 2 8 theta. Now, you should look at that and be like, well, that's actually kind of ugly the way you wrote that. Well, fine, we'll clean it up. Negative 8 sine 16 theta and kapowie. What do we have? G theta? So G prime theta is equal to, oh, did you get that one right? Or did you Wolfram alpha it? Ah, I bet you got scared and went to the old Wolfram. That's all right. I forgive you if you Wolframmed alpha that thing. So anyway, so that was just a good lesson in spotting 2 sine, cosine. And don't let the little 8 theta mess you up when you're doing that. It shouldn't. So let's move on. I'm going to do one more on this video. Let's take a look at this guy. Oh, he's easy. First off, I'm going to rewrite him. I don't like that. I'm going to rewrite this to be log of x squared minus 9 to the half. And now you got to think, how do you do, if I just had log of 2x, what would I do? Well, I would go, the derivative of log 2x is 1 over 2x times the derivative of 2x. And so my answer ends up 1 over x. Fascinating. It's the same thing here. Take the derivative of the whole thing. Well, it just ends up 1 over x squared minus 9 to the half times the derivative of x squared minus 9 to the half. So what's the derivative of just this? Well, let's see. The derivative of that would be 1 half x squared minus 9. Now, go back, subtract 1, and that becomes negative a half. That's where everybody always misses this, is when they subtract that. Times the derivative of x squared minus 9 on the inside, which would just be 2x. Hey, there's some cool stuff on this one. First of all, check this out. That 2 cancels that. And look at what you've got. This one over here is to the negative half. So what you've got going here is 1 over x squared minus 9 to the half root times, you're timesing that by 1 over x squared minus 9 to the half root times x. Hey, this one's actually got kind of a neat end. What do you get when you multiply x to the half times x to the half? Well, add your exponents, it's 1. So what happens is here, when you multiply these two guys on bottom, you end up with x over x squared minus 9. And this is, I can't remember what we started with. Was it a y maybe? A y, sure. Why not? Y prime, my first derivative is that. Bam, and I am finished. I've got some more. I think I got time for one more. So let's do one more. Oh, this is what I take my time to do. Oh, goodness. First thing, rewrite it. Tangent x. Slide that square out there. If it said fourth, I'd slide it out there. And now just do your, it's a chain rule question. No products, no quotients. This would just be 2 times tangent x times the derivative of tangent x, which is square x. And so my answer is 2 tangent x secant square x. Could we try and put an identity in this? Well, yeah, we could. I mean, secant square x would be tangent square x plus 1. I don't think that would simplify our answer any. But, I mean, we could do it. I don't know what Wolfram would say on this. But, I mean, it would be tangent x times. I don't feel like we're simplifying an answer here any. But we can work it out because this ends up being, yeah, I think this is just ugly. Because this becomes tangent cube x plus tangent x. We've not accomplished anything there. I'm going to stick to right up here with this guy. That's my answer. Oh, yeah. That's going to be my answer right there. Okay, one more, and you got me. Oh, my goodness. What in the world is this guy? No problem. Just remember, if you've got a plus sign in here, do the problem. It's 2 problems in one. This is one problem, and that's one problem. So 1 over x is x to the negative 1, which derivative of that would be negative, oh goodness, x to the minus 2, which would be negative 1 over x squared. And so there we go. Now that's my whole derivative of 1 over x is negative 1 over x squared. Now what about this cosine? Well, let's rewrite it. Cosine x half, which becomes half cosine x to the negative half power times the derivative of cosine, which is negative sine, theoretically times the derivative of x, which would just be 1. And so we end up here with negative, ooh, goodness, this thing is going to be ugly. Sine x, I know you're thinking, hey, we're going to have a tangent. No, we don't. Cosine x to the half power. So we don't have problem. Hey, where did I go? I just lost this thing. There it is. So let's clean this up. This answer is negative, let's write in red, negative 1 over x squared minus sine x over, I forgot my 2. Nobody, why didn't you remind me? So that 2, and I'm going to rewrite as radical cosine x. And this is my final answer for that derivative. I don't even know what number we're on now. I've lost track. Doing so many. I think that is number 10. I've got about 7 or 8 more I want to do, but I'll make that a second video. But anyway, that's 16 minutes of straight up derivative mania. So anyway, thank you for watching. As always, peace, love. Hot wings are always acceptable, except the dry kind. I like wet hot wings. You know, the ones with like sauce and butter. And never mind.